Okay, Wackets. Today we're looking at the start of the third 6 weeks, and that's going to start with Wednesday, November 7th, radical expressions and rational exponents on page 31. If you would, update your table of contents. All right, now your table of contents is updated. Let's take a look at the notes. All right, radical expressions and radical exponents. Properties of nth roots. For a is greater than 0 and b is greater than 0, product property of roots. N to the a times b is the same as nth root of a times nth root of b. The quotient property of roots. The nth root of a divided by b is the same as the nth root of a divided by the nth root of b. All right, rational exponents. And the exponent 1 divided by n indicates the nth root. So a to the 1 divided by n is the nth root of a to the first power. The exponent m divided by n indicates the nth root raised to the m power. So a to the m divided by n is the nth root of a to the m power. All right, properties of rational exponents. Product of powers property is a to the m times a to the n is equal to a to the m plus n. Quotient of powers property, a to the m divided by a to the n power is equal to a to the m minus n. Power of a power property, a to the m to the n power is a to the m times n. Power of a product property, a times b to the m power is the same as a to the m times b to the m. Power of a quotient property is a divided by b to the m power is this equal a to the m divided by b to the m. So if you would, update your notes. Now your notes are updated. Let's look at the examples. All right, so example 1. Now this one uses the example 1 uses this property right here. N to the AB is nth root of A times nth root of B. So this would be equal to the cube root of 27 times the cube root of x to the 6th power. Let me zoom in a little bit. There we go. All right, the cube root of 27 is 3. And then this becomes x and we're going to use this right here. So n here, a to the n power here, so that's m divided by n. So that would be 6 divided by 3, which equals 2. So that's 3x squared. All right, let's take a look at example 2. All right, example 2 is identical to example 1. So that would be the 4th root of 81 times the 4th root of x to the 12th. The 4th root of 81 is 3. And then this would be x to the 12 divided by 4. So this would be 3x cubed. All right, so finish up example 1 and example 2. All right, let's look at example 3. So now the quotient works just like the multiplication. So this is equal to the cube root of x cubed divided by the cube root of 7, which equals x to the 3 divided by 3 divided by cube root of 7, which that's x to the first power, but x to the first power is just equivalent to x. So that would be x divided by the cube root of 7. Now, here's a problem. You can't have radical and denominator, so what you have to do is get rid of the radical. And the way to do that is you're going to multiply this by the cube root of 7 divided by the cube root of 7 times the cube root of 7 divided by the cube root of 7. Now, understand that the cube root of 7 divided by the cube root of 7 is equivalent to 1, because anything divided by itself is 1. So in essence, we're just multiplying this by times 1 times 1. So we're not changing it, we're manipulating so the radical is not on the denominator. Okay? So that becomes x times, now from the rule, you'd multiply the 7 times the 7, so this would be the cube root of 49 divided by now this is unique, and then I'm going to rewrite this with the fraction because this is to the 1 power, 1 power, 1 power. So this would be technically 7 to the 1/3 power times 7 to the 1/3 power times 7 to the 1/3 power. Okay, so still the numerator doesn't change, x times the cube root of 49. But we know from a rule that you can add the exponents, so that's 7 to the 1/3 plus 1/3 plus 1/3, which we know 1/3 plus 1/3 plus 1/3 equals 3/3, which equals 1. So that's just 7 to the 1 power. So our final answer is x cube root of 49 divided by 7. And that's what you have to do when you have the radical in the denominator. All right, example 4. So this would be the 4th root of x to the 8th divided by the 4th root of 3. So first off, this becomes x to the 8 divided by 4. And this still stays 4th root of 3, which equals x squared divided by the 4th root of 3. Now, again, you can't leave the radical in the denominator, so we have to do what we did in example 3. So this equals x squared divided by the 4th root of 3. Now we need to multiply this times the 4th root of 3 divided by the 4th root of 3 times the 4th root of 3 divided by 4th root of 3 times the 4th root of 3 divided by the 4th root of 3. Which equals x squared. Now this would be 3 times 3 is 9, 9 is 3 is 27, so this would be the 4th root of 27 divided by Now we know that we can write this as, that's to the 1, 1, 1, 1. So we can write this as 3 to the 1/4 power times 3 to the 1/4 power times 3 to the 1/4 power times 3 to the 1/4 power. So that equals x squared times the 4th root of 27. Now that's 1/4, 2/4, 3/4, 4/4, which equals 1. So that'd be 3 to the 1st power, and you're done. All right, let's look at example. Well, let me pause for a second so you can get all that. All right, let's look at example 5. All right, example 5. Now, because they are the same roots, we multiply what's underneath, so that'd be the cube root of x to the 7th times x squared, which that equals the cube root of x to the 7 plus 2, which equals the cube root of x to the 9th. And that can be written as x to the 9 divided by 3, which equals x cubed. All right, now, if there's not a root here, we put a 2. So this is a 2 here. So same, example 5 is the same. So that's the square root of x to the 5th power times x to the 4th, which is the square root of x to the 5 plus 4 equals the square root of x to the 9th. Now, that's one way to work the problem, but let me show you another way to approach this. Is this. What if I reorder and put x to the 4th here times the square root of x to the 5th? Now, if you notice, 4 will divide into 2, so we can rewrite this as x to the 4 divided by 2 times, wait for it, square root of, I can rewrite this as x to the 4th times x to the 1, because 4 plus 1 is 5. This becomes x squared times, this would be the square root of x to the 4th times the square root of x to the 1. Well, you can just, if you know that this is that, so you can just rewrite this as x squared. So that's x squared times x squared, and you can just rewrite that as the square root of x. You don't actually have to put the 2. Well, you know you're going to add here, so 2 plus 2 is 4, so that's x to the 4th square root of x. So while that's mathematically correct, this reduces it to the simplified form. All right, so finish up example 6. And let's take a look at example 7. All right, so let's think about this. This can be rewritten as, that negative makes it look confusing, but I don't think it is. If we make this the to rewrite as a cube root of negative 125 squared that becomes 25. All right, now example 8. Same thing, that would become the square root of 4 to the 5th power which would make that equal to 32. All right. So this is the radical form, and then that's simplified. Same thing here, that's the radical form, and that's simplified. Now it says write expressions using rational exponents. So this can be rewritten as 7 to the 3/4. All right, so same thing. This should be written as 11 to the 6 divided by 3, which can be written as 11 squared. All right, example 11. Simplify this expression. Now remember, if you're multiplying, you add the exponent. So this becomes 25 to the 3/5 plus 2/5, which equals 25 to the 5/5, which equals 25 to the 1st power, which is just 25. All right, example 12 is the same way, so that'd be 36 to the 3/8 plus 1/8, which equals 36 to the 4/8, which equals 36 to the 1/2, which equals the square root of 36 to the 1st power, which equals 6. All right, example 13. So this would be written as 8 to the 1/3 minus 2/3, which equals 8 to the negative 1/3. Now, when you have a negative exponent, it has to be rewritten to be positive in the denominator, which is 8 to the 1/3, which is equal to 1 divided by the cube root of 8, which is equal to 1/2. All right, example 14. So this would equal, negative goes in the positive, so that's 1 divided by negative 8 to the positive 1/3, which equals 1 divided by the cube root of negative 8 to the 1st power, which equals 1 divided by negative 2, which is equal to negative 1/2. All right. So with that, now that we've gone through the examples, start working on the assignment and have a wonderful Wildcat day.